Computing knowledge and skills provide the foundation for modern competency in a multitude of STEM-related fields, prompting research on how to best prepare students for the 21st century workforce and for lifelong learning. Collaborative Computational STEM, or C2STEM, incorporates a learning by modeling approach in which students build, simulate, and test models for the synergistic learning of the STEM domain, such as physics or marine biology, and computational thinking concepts and practices.
So what's very difficult and tricky in middle school science classrooms is incorporating computational thinking and mathematics and really seeing kids make the connections between science and math and how modeling actually works in science to make predictions or to learn things about our universe.
Within C2STEM, we not only utilize an evidence-centered design approach to curriculum development, but we have also integrated data tools and domain-specific programming blocks to support the range of student abilities and to ensure we meet required curricular standards and NGSS practices. Our curriculum is supported by formative and summative assessments and preparation for future learning assessments, designed to study how students generalize concepts and problem-solving strategies learned and apply them in new problem-solving situations. We implemented an experimental study in a physics high school classroom over the course of one semester, in which instruction was led by the same teacher and all students were responsible for taking the same classroom assessments. Results indicated that students taught with the C2STEM environment not only showed stronger learning gains in physics and computational thinking, they were more likely to apply more flexible problem-solving strategies on the PFL assessments. But C2STEM does not stop there.
And then what I also love about it is that, we didn't just stop with like the physics, because that's a very kind of easy, like, oh, physics and math and computational thinking. That's great. That's all on like the same plane. I get that. But then we kind of took it to the next level and we applied it to a biological system, which can be very scary because biology doesn't work in a nice linear kind of mathematical equation all the time. So how we can represent these living systems in a very computational way to make predictions about, what happens to corals when the temperature increases, or what happens if their zooxanthellae gets expelled and reabsorbed.
As you can see, there are a lot of exciting new ways to implement computational modeling into STEM classrooms. For more information about C2STEM, or if you would like to integrate this in your classroom, please visit our website today.